Okay, so in this class, we're going to look at this question. This is coming from an assignment paper. And let's see how you're supposed to work out this question. So this is part of a section that we've already looked at, maybe not entirely, maybe in part, but let's see how you are actually supposed to deal with it. Okay, someone trying to join. Okay. So what do you need? Well, in terms of the things that you need, firstly, you need to remember the definition of current. Current is just the rate of flow of charge with respect to time. So this is going to be fundamental in working out what we're in solving what we're dealing with. You see, from this expression, if what you needed was not current, but instead you wanted to find charge, you can easily just make the Q subject of the formula. And in this case, you have IT and then dt. That is just by cross multiplying here. The definition of current is this. And then from the definition of current, you end up with this expression for the dq. When you integrate both sides, you end up with an expression for charge as the time integral of current with respect to time. So this again is going to be very useful with some questions. So for the most part, or for the first parts, this is what we are going to use. And let's see, can we actually put that to the test? Look at question 1 here. The question says, determine the current flowing through an element if the charge flow is given by Q, a function of time, equal to 20. And then we have the exponent of 40. And then we have cos 50t. And then we have the microcoulomb. So just be very careful with your explanation, with the expressions as you copy them. Okay, so this is what we have. Now, how do you solve this? How do you work it out? Well, we're given what the charge is, and the question is asking us to find what? They're asking us to find the current flowing through an element. In some questions, they'll give you the time, but in this case, they haven't given us the time, meaning most likely we're going to get an expression for the current in terms of time. So we're given the charge. Well, since you're looking for current, from the definition of what current is the rate of flow of charge with respect to time. What does this mean? It means that if you know the charge, differentiate the charge once, and what you're going to get is going to be the current flowing through that particular point. Since we have the expression for charge, all we have to do is differentiate it with respect to time. So this now requires you to remember how to perform derivatives. So here we have two parts. We have this part and we have this part. So to differentiate this, we can use product rule. So we want to get the derivative with respect to time of 20 e minus 4t, and then we have cos 50t. So this is what we want to differentiate. Now you can go directly and differentiate this, but by product rule, you recall that if you have two functions u and another function v, these two functions are multiplying, in order to say their derivative with respect to, let's say, a variable x, taking that u and v are functions of x, this will be equal to, you can keep it, it's up to you which one you want to keep first. I can keep u, differentiate v, so v prime here, the prime here just means the derivative of v, and then plus, and then now keep v, and I'll differentiate u. So here I have u prime. So in this case, I can say let u be equal to, so here we have two parts. I can get this to be u. So I can say let u be equal to 20, and then I have e minus 40. Then v will be the other function. Notice that I'm picking everything. 20 is the first part, and cos is the second part. Cos 50 t there. So now I have u and v, and I just need to get their primes. So u prime is the derivative of u with respect to t. So when I differentiate this, all you have to do is remember how you obtain derivatives of exponents. So to differentiate an exponent, remind again, if you have e to the power a function f of t, to differentiate this with respect to t, what do? Differentiate the power of the exponent, multiply it here, so that will be f prime of t, and then e to the same power, it doesn't change. So this is the derivative of this. So this is how you differentiate an exponent. Had it been something like this, and then you have the base, if the base was not e, if the base was a number, let's say maybe 4 to the power some function of t, here the derivative would have been, again, first differentiate the power f prime of t. So f prime, the prime there means the derivative of f. So prime here means you're supposed to differentiate this function. So differentiate the power. After that, if the base is not e, then this has to be ln the base, meaning ln 4. And then after that, then you can multiply with the same function for the power f of t. See, in fact, even this one was this. Even this one was f prime of t, and then it also had ln the base, but in this case the base was e, and then this was multiplying e to the f of t. But the only difference is that ln e here is 1. So because ln e is 1, this part will give us 1, so that's why we didn't write it, and then we skipped to just get this part. So here it was just a reminder of how you differentiate exponents. With that reminder, let's differentiate this term here. 20 is a number, or we'll keep it the way it is. According to how you differentiate exponents, differentiate the power first. So the derivative of negative 4t with respect to t will be negative 4. So the negative 4 will come here. Then what happens after differentiating the power? You have the exponent. So this is going to be e. And then does the power of the exponent change? No, it doesn't. It remains exactly the way it is. So it will be to the power minus 4t. Notice that this hasn't changed. I only differentiated the minus 4t, and it gave me minus 4. This was the number 20, so I didn't touch it. I just brought it down. Okay, so from here, I'll just simplify. This becomes u prime is equal to, when I multiply here, I have minus 80, then e to the minus 4t. So this becomes u prime. Any questions on that? Okay, looks like we're okay there. Now we have to differentiate v. Differentiate v, we see we have cos 50t. Now, same way, refresher on how you differentiate trig functions. So the derivative of cos some function f of t with respect to t, what do? Here, the derivative of cos, so here's how it goes. We can say, first differentiate the argument of the cosine. In this case, it is f of t, multiply it here, f prime of t. After differentiating the argument, now differentiate the cosine. The derivative of the cosine is negative sine. So I'll say sine here. The negative, I'll put it at the beginning. And then the argument remains the same. So f of t. So this is the derivative of cos f of t. Had it been sine, something similar, so first I'll differentiate the f of t, f prime of t. Now differentiate the sine. The derivative of sine is just cos. And then keep the argument exactly the way it is. So this is the derivative of sign. So let's use it now to differentiate V. So if we're going to differentiate this, see how it goes. To differentiate this, meaning I'm getting V prime. First, differentiate the argument of the cos. So the argument is 50t. The derivative of 50t, is going to be 50. So I have 50 here. The derivative of cos is negative sign. So sign will be here. I'll put the negative at the beginning. So I'll put the negative there. The argument doesn't change. So I'll bring it 50t. So that becomes my V prime, the derivative of V. Now I have V, I have V prime, I have U prime. Now I can use them in the definition of product rule of differentiation. So what will be the solution here? Again, you could have just gone directly without having to state what U and V is by just differentiating the expression. Okay, so what are you going to get? So current, which is the rate of flow of charge with respect to time, will just be the derivative of the charge there with respect to time. So by product rule, I have U, V prime plus V, U prime. So the best thing about using U and V is now I can just substitute what is my U. So I defined U here as 20. So I'll just copy this. This is what U is. So where there's U, I'll put that. Next, I have V prime. So what is my V prime? The V prime is the derivative of V, which is this one here.
Sorry, sir, I've got a question.
Go ahead. Yes, you can ask.
V prime, I'm wondering where the negative has come from, since the derivative, you said the derivative of cos is sine.
The derivative of cos is negative sign. Here, the derivative of cos is negative sign. So I wrote the sign here and I put the negative at the beginning.
Okay, noted.
The derivative of sine is positive cos. Okay, so I have U and V in place. Now I have plus, that's U and V prime. Now I need V and U. So I need V and U prime. So what is my V? V is cos 50t. And then V prime. So let's get V prime. That's V prime or U prime. That's U prime. So U prime is this. Okay, now we have our derivative. We just have to simplify this. So the numbers can multiply. 2 and 5, that's 100. So this will be, there's a minus there, so I'll say minus 100. I'll start at the exponent. And then we have sine 50t. And then there's a minus coming there as well, so I'll say minus here. And the 80 e minus 4t. And then we have cos 50t. So this becomes our current function of time. Now, what will be the units? Here, by the way, this is what I was saying, that in some questions, they will tell you the time. They'll say, calculate the current, or they'll say, determine the time, given that the charge is this, and then they'll give you the time frame. In this case, we're not given what the time is. Were we? No, we're not. Determine the current flowing through an element if the charge flow is given by this. So they did not give us the time. Instead, notice that we have the units here, microcoulombs. So what does this imply? It means that when you calculate the current, this is the expression for the current. But the solution, you expect current to have units of ampere. But because of the micro which was present on the charge, you expect this to also carry the microampere. So this will be the expression for the current. Any questions up to here? So feel free to chip in, guys. This is an open discussion, so you're free to contribute, you're free to challenge. Okay, so look at the next one. Cos 10t. This is pi over 6. And again, we have the microampere. But here we're given one additional thing. Q0 is equal to 2 microcoulombs. So we'll see where that will come in play. What else are they saying? The question says, find the charge Qt flowing through a device if the current, so we're seeing something here. If the current is, but look at what this is, Qt. And look at the units here, microampere. So this microampere actually agrees with the statement that if the current is, this is not charge, it's the current. So what they're giving us initially here is not the charge, it's in fact the current. What we're looking for is the charge Qt. So the question says Qt there, but this is not Qt, it's IT. So we'll see if this has to change as well, but for now, let's keep it like that because the units are indicating charge. So keep it like that for now. We'll see where it fits in our formula. Okay, so we have an expression for the current, and then we're looking for the charge Qt. So how do we do it? Well, again, it starts with what we pointed out earlier to say that the definition of current is the rate of flow of charge with respect to time. But from this expression, when we make Q the subject, we see that Qt will be equal to the integral of IT with respect to time. So observe that in the current question, we're looking for charge given the current. So this is now what we're going to use. So how do we do that? So observe that the two questions are similar, this one and the one we're from looking at. In the one we started with, we were given the charge, wanted to get the current, we differentiated. In this current question, we're now given the current, we're looking for the charge, we now have to integrate to get the solution. So how do we do it? Well, we have Qt is equal to the integral IT dt. Now, in terms of the limits of integration, you can keep it open, but if you keep it open, you have to integrate the constant of integration, which you will be able to find. But this is being worked out from t is equals to 0 to some random value t. But the question says one thing here. You see this value here, Q0. Q0 was the charge which was present when time was equals to 0. What you have to see is that the two expressions are additive. So this is what was happening after t is equals to 0 to some value of time t. But the total charge you're finding actually adds what is happening after t is equals to 0 plus the amount of charge which was present when t was equals to 0. So it's like charge is accumulating. At t is equals to 0, we already had charge present. Now, how much charge is going to be added? The amount of charge which is going to be added, which is going to accumulate, will be given by this expression. Have you got that? Okay. Any questions? Okay, let's proceed. So here we have this. So this is now the integral from 0 to t, and our expression for current, we have this. And then the last part is just plus the charge when t is equals to 0, that is 2 microcoulombs. So you have 2 microcoulombs. These, for the most part, will just leave it out. The interest will be here. And this is with respect to time. Now the question is, how do you integrate this expression? That's all we have to do here. Integrate. Okay. Now, how are we going to do this? So to integrate cosine, don't forget, an integral is a reverse of a derivative. So we can choose a few methods here. Okay, so to integrate this, I can choose to use a u substitution, or I can just go directly. So remember how you integrate. If you wanted to get the integral of, let's say, cos f of t with respect to t, then firstly, you'd have to differentiate the argument. In differentiation, after differentiating the argument, you multiply it. In integration, after differentiating the f of t, you divide it down here. Then you multiply it with the derivative of this. The derivative of, not the derivative, sorry, the integral of the cos. The integral of cos, or you're asking yourself is, what did you differentiate to get cos? It's sine. When you differentiate sine, you get cos. So usually a common mistake by students here is they think when it's cos, that's when you get a negative. Here you have to remember, in differentiation, we said the derivative of, where is that? We said, skipped it, past it. We said the derivative of sine is positive cos. So the integral of positive cos is positive sine. So the same way, the integral of cos will be positive sine. And again, the argument remains the same. So this is the integral of cos. So when I use that here, what do I have? So I have qt equal to, since I'm integrating, I'll drop the integral sign. The 20 there is a constant, so I'll have 20. And then what did I say we start with? Differentiate the argument. So if I have 10t plus pi over 2, when I differentiate this, the derivative of 10t is just 10. The derivative of pi over 2 is 0. So we're going to go out with a 10. So differentiate the argument and divide it. So say divided by the derivative from the inside. The derivative there is a 10. So I've differentiated this and I've divided it. Now I need to integrate the cos. The integral of cos is sine. Then the argument remains the same. The argument is 10t plus pi over 6. So that becomes our integral. And this is from 0 to t. Then we still have, so I've done this. So the limits of integration, just 0 to t. Then you still have plus 2 microcoulombs. At this point now, the 10 and the 20 will divide, giving you a 2. Two microcoulombs. And then now substitute the limits. When t is equals to t, this expression will remain the same. Now, what about when t is equals to 0? So let me just play around first when t is equals to 0 so that I see what I will have. Because I know the first part will remain the same. To be 2 sine 10t plus pi over 6. This is when t is equals to t. Then here I have to say minus 2 sine. Now when t is equals to 0. When t is equals to 0, the first term here becomes a 0. And then lastly, now I can put the last part, plus 2 microcoulombs. So it's these that I want that can actually simplify when t is equals to 0. So I'll keep this. So what we have here, this is now minus 2. Then this is sine pi over 6. Then plus 2 microcoulombs. So what is sine pi over 6? Okay, so sine pi over 6, that's the same as sine 30 degrees. And sine 30 degrees is half. So this is the same as 2 sine 10t plus pi over 6 minus 2. Sine pi over 6 is the same as 1 over 2. 2 microcoulombs. And 1 over 2 makes this a 1. So that now we have 2 sine 10t plus pi over 6. And then this is now minus 1 plus 2 microcoulombs. Now we're almost there at the end. But this one has units. I didn't put units for this because we still had to do the integration. But what will be the units for our solution here? Well, it starts with the observation that the current which was given had microampere. So when we get, since here the key is we did not multiply this with any other quantity that is coming with units. Because of that, we can actually just get the fact that this will also come with micro. If we had to multiply micro with micro at some point, of course, the units would change. Here we did not. So meaning even our solution will have microampere. Meaning this has microampere. Even the one here has microampere. Meaning, not microampere, sorry. This is charge. So it would be microcoulombs. So meaning this and this are actually like terms. So that our overall solution will be 2 sine 10t plus pi over 6. And then this will be plus 1. And then this will all be in microcoulombs.